Hello engineers, welcome to Mechanical Training World channel. In today's video, we are diving into an important topic from ASME Section VIII Division 1, that is UG-37 reinforcement required for openings in shells and formed heads, guys. To make this concept easier to understand, I have broken this concept into three parts. In this first part, we will explore the core concept and the fundamentals behind the UG-37. So imagine a pressure vessel, an engineered shell designed to contain fluids under immense pressure. Its strength lies in uniform and uninterrupted structure, right? But what happens when we need to pierce this armor? We produce openings for inlets, outlets, gauges, and sensors installation, right? These are essential for operation, but every hole we cut is a compromise, guys. It's not just a gap in the metal, it's a loss of strength and reduction in visual ability to withstand the pressure. So let's understand why openings weaken the visual, guys. When we remove a material from the shell, we reduce the cross-sectional area, right? For example, here you can see this is the vessel and here we provided a opening, which results stress concentration here. So, which makes potential failure in the vessel. So, the vessel is no longer uniformly stronger, guys. To restore the vessel integrity, we don't just patch the hole, right? We are engineers. We need to provide a solution. That solution is providing the reinforcement pad, guys. So that's why we add reinforcement pad around the opening, guys. So it replaces the lost material and redistributes the stresses. It ensures the vessel can withstand the same pressure as before without compromise, guys. So, but the problem is where we need to compensate this reinforcement pad, where we need to provide this reinforcement pad, guys. So, however, not all compensation is effective. Incorrect compensation means, for example, this is our opening. If you provide reinforcement pad somewhere else, like here, so there is no use, right? So adding a material far from the opening does not restore strength at the weakened area, guys. This is our weakened area. It does not if we provide reinforced pad somewhere else means it does not restore strength at the weakened area. It fails to support the stress concentration caused by the opening, guys. So correct compensation means placing a reinforcement pad directly around the opening, guys. This will ensure that the added material effectively redistribute the stresses and restore structural integrity. So this is why reinforcement pads are designed and positioned strategically around the opening, guys, but not arbitrarily or elsewhere in the visual, guys. I hope you understand where we need to add reinforcement pad. So before going to the next step, I'm trying very hard to give quality content, guys. If you feel this information helpful, please subscribe my channel and click on the bell icon and hit the like button as well, guys. So this video will reach more audience. So let's go into the next point. So that is basic methodology behind compensating material lost due to opening, guys. For example, this is our opening. This is our opening, right? That is, this is the diameter of the opening. So we need to compensate with reinforcement pad. So whatever in the yellow color you are seeing here, it is reinforcement pad, guys. So for diameter of the opening, we are compensating d by 2 and d by 2 around the opening, guys. This is how we need to compensate the material around the opening, guys. So what we did here, we will consider the volume lost in the area by looking at the cross-sectional area of the opening. Now we can see in the figure above that the opening area is divided into two equal parts and placed right next to the opening. So the area lost in the opening is now added back to the shell, and if we revolve the area we added, then we will get reinforcement pad that is required to compensate for the opening. I hope now you understand how to replace the area lost in the opening, guys, with the reinforcement pad. Set-in and set-on nozzles. So in pressure vessel design, set-in and set-in nozzles are referred to different ways of connecting pipes to the vessel, guys. So the very first one is set-in nozzle. In set-in nozzle, it is a type of nozzle that is welded to inside the pressure vessel. Here you can see the blue color one, that is nozzle, guys. So it is welded inside the pressure vessel wall. So this type of nozzle is also sometimes referred as welded in nozzles. And next one is set-on nozzle. So it is a type of nozzle that is welded to the outside the pressure vessel. This is the shell and this is the nozzle. It is welded on the shell, guys. It is outside the shell. Okay. This type of nozzle is also sometimes referred to as weld on nozzle, guys. So I want to clarify one thing, that both set-in and set-on nozzles can be reinforced with reinforcement pads. So the based on the configuration of the opening, the reinforcement requirement changes, guys. So we will look into different requirements of reinforcement later. So this is all about basic concept behind the UG-37. In next lecture, we will see area required for compensation of openings in the pressure vessel, guys.